Today we're going to talk about parallel and perpendicular lines. So we're going to be starting out with two quick investigations to look and see what we notice about the slopes of parallel and perpendicular lines. So our first question says, how do the slopes of parallel lines compare? So parallel lines are two lines that are evenly spaced and do not touch. So on our graph we have two lines that are evenly spaced and do not touch. Now, there's a place for us to state the slope of line 1 and line 2 and then write our conclusion, but I did not specify which one was line 1 and which one was line 2. So I think I'm going to choose to let this be line 1 and the one on the bottom be line 2. But it really doesn't matter. We're just trying to see what we notice about our slopes. So to find the slope is kind of the roadmap of how you get from one point to the next. So if I can, I like to try to find the y-intercept first and then see how do I get to the next point, or even just where is the next point. So if I follow my line along, the next one is not at the corner of a grid line, nor is this one. But I think this one might be. So I am going to check. We are going 2 squares up and 3 squares over. So I'm going to try it again. 2 squares up, 3 squares over. Am I still on the line? Yes, I am. So I'm pretty sure this one here is going 2 squares up on y and 3 squares over. And the numbers are getting bigger. We started at an x value of 0, and now we're at positive 3, so it is getting, the x's are getting bigger by 3. So the slope of this line should be delta y, the change in y, divided by delta x, so it's going to be 2 over 3. So the slope of line 1 is 2 over 3. Okay, let's take a look at line 2. So for line 2, same thing. I'm going to try to find the y-intercept first, which appears to be down here at -2. And then I'm going to see if I can find another point. Now, I apologize, when I drew this on my page, my ruler moved, but the one on your handout should be a little bit easier to work with. So I'm looking to see if there's another point, and I believe in my very badly drawn line that would be here. So if we've gone 1, 2 squares up and 1, 2, 3 squares over, I'm going to try going again. So 2 squares up and 3 squares over, and then if I go backwards, 2 squares down, 3 squares over. So it is, once again, going up 2, and then on x we are adding 3. So the slope of line 2 is 2 over 3. So what do we notice about the slopes of those lines? They're the same. So when you have two parallel lines, they are evenly spaced, which means they need to continue to be evenly spaced, so they need to be on the same trajectory or path, so they would actually have the same slope. So my conclusion here is that parallel lines have the same slope. So anytime you have two lines that are parallel, they will always have the same slope. That's what keeps them on the same direction so that they stay evenly spaced. If their slopes weren't the same, they would eventually angle towards each other and would cross at some point. So you can join me in the next video to look at the investigation on perpendicular lines.